Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 4th, 2025, about 3 days ago. This paper introduces mutual information tree search, a step-by-step scoring approach using Pointwise mutual information that guides beam search without rollouts, and it beats prior methods, for example on strategy QA, reaching 68.45% versus chain of thought at 47.34%, a plus 21.11% jump. The paper is titled MITS, Enhanced Tree Search Reasoning for LLMs via Pointwise Mutual Information, and as we'll see later, the results are really impressive. Beyond accuracy, it adds entropy-driven dynamic sampling and consensus-weighted voting, delivering stronger reasoning with far less compute than Monte Carlo-style search. Alright, Figure 1 shows the full MITS pipeline that scores and steers reasoning paths, so the model explores promising steps without expensive rollouts. The top middle panel illustrates dynamic sampling, which allocates more candidates when token uncertainty is high. The lower middle panel depicts beam search that prunes low pointwise mutual information paths to keep compute tight. On the right, the weighted average voting module aggregates the top chains and selects the final answer, with colors indicating pointwise mutual information strength. With that setup covered, Figure 2 shows prompt examples that drive step-by-step generation. The figure illustrates a chain of thought style instruction that cues the model with, "Let's think step by step," which encourages explicit intermediate steps. A special step marker delimits each chunk, so the generator emits one step and then stops. This structure lets the evaluator score the new step and decide whether to expand or prune the path. So, Figure 2 showed the prompting. Table 1 now reports accuracy gains across models and datasets. The table indicates that the method generally leads, because pointwise mutual information scoring and consensus voting steer search toward consistent answers. In the top strategy QA block, accuracy with HuWin 2.53b reaches 68%. In the middle ARC challenge block, QWin 2.57b records about 93%. In the bottom common sense QA block, Phi 3.5 mini peaks near 91%. Figure 3 shows how accuracy changes as the number of rollouts increases. A rollout here means the count of sampled reasoning chains, which is the budget for exploring different paths. Across all 4 models, the red curve stays on top because pointwise mutual information scoring finds good paths quickly. With just 2 rollouts, it already leads, and it keeps improving as budget grows. RAP occasionally dips at higher budgets, while R* and chain of thought self-consistency rise more slowly. Wrapping up, 2 takeaways stand out. Pointwise mutual information scoring gives a reliable step-by-step value estimate so beam search finds strong reasoning paths quickly, and entropy-driven sampling plus consensus-weighted voting make the final answer robust with far less compute. The implication is scalable, plug-and-play reasoning for many large language models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.